Good afternoon, everyone present here. My name is Om Doshi, roll number 166, with my teammate Sahil Dangwal, roll number 167. The title of our paper is Application of Milli Machine and Recurrence Relation in Cryptography, published by IJERT in the year 2013. Moving to the contents, the first one is the introduction, second is proposed algorithm, followed by performance analysis with security analysis, implementation, and concluding remarks. Moving to the introduction, cryptography is the study of techniques for ensuring the secrecy and authentication of the information. DFA, also known as the deterministic finite state machine, is a finite state machine that accepts or rejects finite strings of symbol and only produces a unique computation. Secret sharing scheme is proposed using finite state machines. The motivation of secret sharing is to have secure key management. The basic idea in secret sharing is to divide the secret key into pieces and distribute the pieces to different persons so that certain subsets of the person can be together to recover the key. Moving to a second topic, which is the proposed algorithm, the encryption is as follows. It is represented plain text with a double underscore p dash. The second is divided the plain text into n numbers of text, that is into square matrix. Def- define a finite state machine through public channel, followed by define the input. Get output through finite state machines, followed by the defined recurrence matrix, and choose recurrence relation. The seventh is the define the value of n of recurrence relation. Step 8 is to define the ciphertext at each stage for all the plain text. The 9 is to send the ciphertext to the respective receiver. Moving to the performance analytics, the first is the mathematical analytics. The recurrence matrix and elements of recurrence matrix are different at each stage depending on the input and the output. It is very difficult to break the ciphertext without proper key, defined operations, and the choose finite state machine. The key is defined as the sum of the elements of this plain text. Moving to our next topic, which is the security analytics. Here we have the column such as name of the attack, followed by the possibility of the attack and the remarks. So the first one is the ciphertext attack, where the possibility of attack is it is difficult to crack the cipher key, and the remarks are as because of the chosen finite state machine and the key. The second is the known plain text attack, where the possibility of attack is very difficult, and remarks is because of the chosen finite state machine and key. Third is the chosen plain text attack, which is difficult as in the case of possibility of attack, and the remarks are because of the chosen finite state machine and key. The fourth is the adaptive chosen plain text attack, where the possibility of attack is also difficult. Remarks is because of the chosen finite state machine and different individual keys. The fifth is the chosen cipher key attack, where the possibility of the attack is too different to crack ciphertext. Remarks are because of the chosen finite state machine key and the recurrence matrix. The last but not the least is the adaptive chosen ciphertext attack, where the possibility of the attack is too difficult to crack ciphertext because of the chosen finite state machine key and chosen recurrence matrix at each channel. It is also as the extracting the original information from the cipher key is difficult due to the selection of the recurrence matrix, secret key, and the chosen finite state machine. Brute force attack on key is also difficult because of the key size. Now the implementation will be explained by my teammate Sahil. So you can. Thank
Okay.
you.
So now talking about the implementation. So we assign 1 to a letter A, 1 to the letter A, and 2 to the letter B, and so on, and 26 to the letter Z. So we assign 27 to full stop and 0 to space. So now, for example, let us encrypt the sentence birds are singing. So the steps would be P will be equal to the birds are singing. So, and this sentence has 18 characters which include space and a full stop. So as you can see, this is the matrix for it, where, and now we apply the remaining algorithm to plain text A and B. So the Mealy machine is publicized through public channel. So all the elements of both the plain text are added and converted into binary form. So, and this is the input. So the sum of all the plain text A is equal to 76, which is equal to 1001100, and B is equal to 106, which is equal to 11011010. So the fifth step will be the output of the above key is found with the help of Mealy machine. Then this is the recurrence matrix, which is defined as you can see here. R Rn is defined as the recurrence matrix. So the elements of the recurrence matrix are taken from a recurrence relation. Uh, so yeah, this is as you can see the implementation table, where if you take the input 1 and output 1 and the value of n1, you can get the following key values and ciphertext. Where, for example, the key values here are in the matrix form, with the first row as 131, second row 317, and third row 171. And the ciphertext in the same way, in a matrix form, where the first row contains elements like 1, 22, and 10, 17, 18, 16 in the second row, and in the third row 15, 14, and 28. So in the same way, this is the implementation table, where you can take any input and output. For example, in this case, the input and output is 1 and 1, and the value of n is also 1. So you can see the key values and ciphertext for the corresponding values. And finally, the seventh step is let Ci plus 1 be the ciphertext as Ci plus ith state, which is defined as Ci plus 1 is equal to Ci plus Rn, where Rn depends on the input. So Rn is basically format sequence when input is equal to 0, and Mersenne sequence when input is equal to 1. And the eighth step would be calculate ciphertext at each state. So now coming to security analysis, as you can see, this is the same table that we had, where we can take the corresponding input and outputs and value of n and gain the key values and ciphertext. So the as you can see, it sends this following ciphertext to receiver 1 and the ciphertext to receiver 2. So now finally, coming to the conclusion, the algorithm proposed is based on the finite state machine and operations on matrices. Secrecy is maintained at 4 levels. So these 4 levels are the secret key, the chosen finite state machine, the different operations, the recurrence matrix. The obtained ciphertext becomes quite difficult to break or to extract the original information even when the algorithm is known. Hence, the algorithm proposed is based on finite state machine and operation on matrices. Thank you.